multiply each and state the restricted value. So if you look at the first rational, 1 over x minus 4, you can't do anything with this. So if you look at the second fraction, or the second rational, we have x plus 2. Since we don't want to work with a negative, I'm going to factor the negative, so you have x squared minus 9x, and you're going to see y right now, plus 20. So to check, you have negative times x squared gives you negative x squared. That checks. A negative times a negative gives you a positive 9x. And then a negative times a positive gives you a negative. So that works out. So now what I'm going to do is I'm going to factor. So you have 1 over x minus 4 times, and you have the factors of 20. And I know that it's going to be negative 5 and negative 4. So you have x minus 5 and you have x minus 4 divided by x plus 2. And you notice that x minus 4 divided by x minus 4 is 1. So you have negative parentheses x minus 5 divided by x plus 2. And when we go back to restrictions, we have to look at this denominator and we have to look at this denominator. So we know that x can't equal 4 or x can't equal negative 2. There are times that we look at a problem and we don't know how to begin. So we know we have to multiply the two fractions. But before that, we want to see if we can factor. So we look at the first fraction and we look at the numerator and we ask ourselves, is there anything in common? And we do know that there's a 7 and there's also an a that's in common with these two terms. So what I'm going to do is I'm going to factor. So I have a minus 7 times what gives you 28. So it's 4. And you're going to notice that I don't have an a there because I factored out the a. And in the first term, there was an a there. So I'm going to go ahead and divide. A minus 4 is already in factored form times 1. There's nothing to factor from 1. Now you can do this 5 times a, and that helps you to figure out which are going to be 1. So we notice that a minus 4 is repeated in the denominator. We know that a is also repeated here in a, so that's the only thing that we can say is going to become 1. So a divided by a is 1. A minus 4 divided by a minus 4 is 1. So we're only left with 7 in the numerator. 7 times 1 gives you 7. And we're left with 5a in the denominator. And you notice that we still have to talk about our restrictions. It's whatever is going to make this denominator 0. If we put a 4 here, if we put a 4 there, we're not able to divide by 0. So that's our first restriction. And over here, we can't put a 0. So a can be 0. So for number 9, we have a rational and then we have an expression. So we're still going to go through the process of figuring out, is there anything that we can factor? Now we notice that we have k minus 4. We can't factor anything from k minus 4. Now you do notice that there's 27, there's 27. That's a common factor. And we have k and we have k. That is another common factor. And you're going to have k plus 1 times, now if you look at this expression, you notice that they have 3 in common. So you factor the 3, so you're left with k plus 1. Now, before we do the restrictions, we're going to see if there's anything that we can make when you divide it becomes 1. So k plus 1 divided by k plus 1 is 1. We also notice that 3 is divisible by 3 and 27 is divisible by 3. So what I'm going to say, this is going to be 1, and 27 divided by 3 is 9. So the restrictions, and when I say restrictions, we can't have a negative 1 in there because negative 1 plus 1 gives you 0, and that's going to bring the denominator 0, and we can't divide by 0. So k cannot equal also 0 because that's going to make the denominator 0. So remember, make a note, 1 divided by 0 is undefined. So that's why we have those restrictions. So we have k plus 1 divided by k plus 1 is 1. We've already said that 3 divided by 3 is 1 and 27 divided by 3 is 9. So we're left with k minus 4 in the numerator and then we're left with 9k. So now we're not multiplying fractions, we're dividing. So we have p minus 7, which itself is a factor, divided by 8. Now this will become multiplication. And then what you have to do is you have to find the reciprocal of this fraction. So what you have is 8p, you have 8p plus 8 divided by p plus 5. The first restriction occurs right here. If we put a negative 5 for p, that's going to make the denominator 0, so that has to be restricted or eliminated. You can't use that negative 5. And also, if you use a negative 1 up here in the numerator, that's also going to make, this will also make, negative 1 will also make the denominator 0. So now I have p minus 7 divided by 8 times, you see they have a common factor, you have 8. So you have p plus 1 over p plus 5. So 8 divided by 8 is 1. So what you have in the numerator is p minus 7, p plus 1 divided by p plus 5. And so this up here, these two fractions will simplify and give you this expression. When I saw problem 19, I noticed that I have 9r plus 90 and I have 9r plus 90. I also noticed here that we have a 4 and we have a 4, which indicates to me that there's going to be, it's not going to be a very hard problem to do to simplify. So we have 9r plus 90 divided by 4. Remember that the division in a fraction problem is going to be multiplication now. The second ratio, you're going to have to find the reciprocal. So you have 4r squared divided by 9r plus 90. Now you notice when we look for common factors, we have 9 plus 90 and we have 9 plus 90. We know that that's going to be 1. We also notice that we have 4 and we have 4, and that's also going to become 1. And so this will simplify to r squared. But before we do that, we need to figure out what are the numbers that we're not able to use in this expression. So we know that r, since r was in the denominator, automatically we know that 0 can't be there. And if I put a negative 10 for r here, it's going to make it negative 90. So that's our other restriction. R can't be negative 90. Question 23, what made this difficult was actually the second fraction. When it comes down to simplifying, we have 7v plus 5 divided by 7. Division will become multiplication. And now we have the denominator that's in the numerator. So before I do that, I'm going to factor. Here, I'm going to do this here. I'm going to factor. I'm going to factor a 2, since 4 divided by 2 is 2 and 10 divided by 2 is 5. Now you notice you have v to the third and you have v to the second. You can always factor the least amount. So you have v to the second. And so what we're left with is 2v plus 5. So I'm going to write this on top. 2v squared parentheses 2v plus 5. I'm going to factor 14v squared plus 45v up here. So I'm going to multiply 14 times 25. That gives you 350. So you have v squared plus 45v plus 350. You're going to look at 350 and tell me two numbers you can multiply to get added to be 45, but also multiply to give you 350, which we know is going to be v plus 35 and v plus 10. And what I did is you got to figure out the different combinations, but I know that 350 times 10 gives you 350, and 350 plus 10 gives you 45, and that's what I wanted. Now remember, in our process, I went ahead and took out the 14, so we divide by 14, we divide by 14. Now 35 over 14 has a 7 in common. So that's 5 over 2. So you have v plus 5 over 2. The other fraction is 10 over 14, and they have 2 in common. So it's 5 over 7. 10 divided by 2 gives you 5. 14 divided by 2 gives you 7. So it's v plus 5 over 7. And the way I taught you was the 2 is going to go up to the top. So you have as your factors 2v plus 5. And then the other factor will be 7v plus 5. And you notice there's some common factors. 7v plus 5, 7v plus 5, 2v plus 5, and 2v plus 5. And so this is in the numerator, this is in the denominator, this is in the numerator, this is in the denominator. So this will simplify to 2v squared over 7. Now the easiest thing to figure out for restriction, we know that since this was in the denominator, so v can't equal 0. That's the first one. Now to find out the other ones, you're going to have to set 2v plus 5 equals 0. So I know when this is going to be 0. So it's 2v equals negative 5. So v can't equal negative 5 over 2. That's just simply solving an equation. And over here we have 7v plus 5. We want to know what v is going to make it equal to 0. So it's going to be 7v equals negative 5 and then divide by 7. So we know that v can't equal negative 5 over 7. So the actual restrictions are 0, negative 5 over 2, and also negative 5 over 7. So I'm going to do 26 since I didn't do it in class. We're going to go ahead and we're going to say that we can factor here 8k squared. So we're left with k minus 2. And here you have k minus 5. You can't do any factoring. Remember that division becomes multiplication. So you have 5k plus 2. So now you're going to have to factor a common factor in this expression. So what you can factor here is 8k squared. It's always the least amount that you can factor. So it's 5k plus 2. So this will be 8k squared times 5k plus 2. I know I put an x, that's supposed to be a k. And you notice that 5k plus 2 and 5k plus 2, that's going to become 1. 8k squared and 8k squared cancel. So you're left with k minus 2 over k minus 5. The restrictions, k can't be 5. And the other one was 5k plus 2 equals 0. You subtract 2 from both sides and then divide by 5. So that will give you the restriction. So k can't equal negative 2 over 5. Number 28, we have 50n, which is 2 times 25, which is 5 times 5 times n. So I made it in factored form. Here you have 2n squared, you have 18n, and you have 28. So the greatest common factor is 2. And you're left with n squared plus 9n plus 14. So what are the factors of 14 that when you multiply add up to be 9? And you know that's going to be n plus 7 and n plus 2. And what you're multiplying is by 2n plus 4. You know the common factor is 2. So you're left with n plus 2. And you notice you have n plus 2, you have n plus 2, you have 2, and you have 2. So you're left with 2 times 5, which is 50n, over n plus 7. So n plus 2 and n plus 2 become 1. 2 divided by 2 is 1. So now our restriction is n can't be negative 7 and n can't be negative 2.